Hi friend, continuing after the last video where I have told you the statement of KCL and what will be the sign to be taken for entering node current or current leaving the node. Now we will continue the lecture that why we use KCL. KCL is mainly used to find out the unknown current in any branch. Unknown current in any branch by finding out the node voltage. By finding out the node voltage. Take a simple example here that this is a circuit this is suppose this is 10 volt 2 ohm, here also 2 ohm, this is 1 ohm, and this voltage is suppose 6 volt. I will have to find out this current, that is I. So to find out this current I must take this node voltage as V, and for my ready reference I will always take this V, this value of V, this is always, I will take this as greater than this voltage and greater than this voltage. This is only my assumptions, it may be greater than this or may not be, but I will take that this V is greater than this voltage and this voltage. Okay, so I'm just, as this is greater than this voltage, then current direction will be from this point to this, as current will flow from high voltage to low voltage, so I will assume that this current is flowing in this direction. This is suppose I1, another is V, and this is ground potential, so this is greater than this voltage I am assuming, so I will take this is I2 flowing downward from this point, this node. Now the third one is, as I have taken V is greater than 6 volts, so this V will flow, this V will allow to flow a current in this direction. I will take it as I3. So what my condition is, V will be greater than 10 volt and 6 volt. Okay, so this is my condition. Now according to KCL, I am applying the KCL here, that is in this node. So from here I can say this 3 current, I have taken this direction as positive because 3 are leaving the node. So I1 plus I2 plus I3 is equal to 0. Now what is I1? This voltage minus this voltage divided by this resistance. So V minus 10 divided by 2. What is I2? I2 is this voltage minus this voltage, that is 0 volt, by this resistance, that is V minus 0 by 1. What is I3? This voltage minus this voltage divided by resistance 2, resistance of the branch 2. So this is my B minus 10 by 2 plus B minus 0 by 2 plus B minus 6 by 2. So I can find out easily that this is B minus 10 plus 2V plus B minus 6 is equal to 0. So I can find out 4V minus 16 is equal to 0. So V is equal to 16 by 4, that is equal to 4 volt. Okay, now I will have to find out this current I. So what is I? Here I have taken that I2 is flowing from this point to this point, that is to the ground. through this 1 ohm resistor. So the current direction I have taken for I2 is just opposite in direction of the current to be find out. So I am taken this I as negative. So finally I can say that I, which I will have to find out, is equal to minus of I2, and minus of I2 is nothing but minus of V, that is the voltage. V node voltage is 4 volt, so minus 4 divided by 1, that much ampere, that is minus 4 ampere. Okay, suppose another example I am taking, and in this example here the voltage is 10 volt. Okay, I am choosing the resistance value same as above, but there is a current source of 2 ampere. Okay, so what I will have to find out, the same procedure will be followed here, and I will take this node voltage as V, this one is I. Suppose again the same current is required, that is I equal to how much, this is I2, this is I1, and here I can easily find out that as this is the current source, so current in this direction is nothing but the what, 2 ampere. Okay, so I can write down the KCL here. I1 outward, so positive, I2 outward, so positive, but this 2 ampere current is inward, so negative is equal to 0. So I1 is equal to V minus 10 by 2, as I have told earlier that I will take this V, I will assume this V as greater than this voltage, this V greater than 10 volt in this case, and obviously this is in ground potential, so it will be obviously greater than this potential. So I1 is equal to V minus 10 by 2 plus V by 1 is equal to 2. Okay, so V minus 10 plus 2V is equal to 4. Okay, so 3 volt is equal to 14, that's in V equal to 14 by 3, this much volt. Okay. Now the current is same here, I is in opposite direction of I2, so I minus I2, so it equal to minus of 14 by 3, as resistance is 1, so it divided by 1, that much ampere, so minus 14 by 3 ampere. I hope this the lecture based on KCL will help you to just understand what is the basic of the KCL. Okay, if you like the video, then please subscribe to the channel and like the video. Then I will upload more videos related to the circuit theory portion. Thank you all. Best of luck.